Can you hear me? So I'm glad that you are all here today with us to present for you the recommender model for ranking matching houses. I hope you have some energy left for us because it's 5:45. So, yeah, my name is Dania. I'm a data science recent graduate from Bologna Business School, and previously I was working as data analyst. And I have with me
And
Yara.
I am Chiara, and I recently graduated in statistical science, and now I'm working from 6 months at the engineering company in Padua.
Yeah, and we both worked on this model during our internship at engineering. So, as you know, like nowadays, like world is full of information that like a vast amount of information is being generated every second. And once you are browsing the internet, you can see like a lot of information when you are searching for simple stuff. So you will be, and all the brands, all the companies want to grab your attention, so they will load you with a lot of information. And you will end up like this poor guy, and you will say like, this is too much information for me. I just want the customized information that is based on my preference when I'm searching for simple stuff. So this was our case for real estate. So in our case, I'll just give you a brief and a simple introduction of what is recommendation system in case you don't have any idea about this. So the simplest definition of recommending system is a subclass information filtering system, which is seeking to predict the rating and preference of a customer would give to an item. And this was one of the main phases for our model, and the second phase was how to have a ranking mechanism for our model. So what was the business goal behind this project? So the main goal was to create an efficient and accurate engine that is matching real estate for the customer portfolio based on their references. And so the system should have like data of real estate that is taking the customer request of what kind of houses they are searching for. Then we will give them back best matching houses based on their preferences and their profile, of course. So here you can see the general workflow of the model that we have implemented, starting from the customer is inputting a new query for their preferences to a happy customer, not like the poor guy that we saw in the beginning. So as I have said, like the model was based on two main phases. So the first thing was to build a recommendation. And this was done by inferring of like implementing two models, which are the GLRM and deep learning with autoencoder, which I will go in deep in the next few slides. And then we have the ranking mechanism, which is like after having a complete data set of the houses, we need to have a ranking mechanism to give back to the customer best matching houses for their preferences. For today's presentation, we have used American Housing Survey for a purpose to show you a demo. So we have an open source, and it's a national public file that every record is associated with the housing, with the household profile. So it's like it has all the features of the house with the householder profile that we have. The methodology and tools that we have used, so in the first phase was to build the recommendation, as I have mentioned before. And the inferring of NA for this phase, the main goal was to create, to inferring the features that was not selected by the user. For this purpose, we have used, as I said, like two models, generalized low ranking model and deep learning with autoencoder to inferring the house features based on the available data that we had in the history. We implemented these two models with the H2O package. And the main idea behind implementing it with H2O, besides it's an open source software, it has like a large range of advanced machine learning algorithms that you can like implement. So you will have, while you are working with different models, you will have a constant of one package that you can build all your different models from. And as well that H2O is a framework that enable you to work with big data framework, and it has its own internal data structures that you can play around with, and it's efficient and like it has an optimal efficiency because it's done with the fine-grained parallelism, as well as it's allowing you to serialize your work based on node or cluster or combined both together. So for this model, the generalized low rank model, as you can see, it's approximating the data set based on the product of two low dimensional factors. And it's taking the most important combination of the features and then recomputing for you the original data set based on the features that was available. And the main characteristic of this model, it was enabling us to deal with the categorical variables because like our data set was heterogeneous and it has a lot of different data types that we need to deal with. So this was one of the main idea to implement the GRLM to impute the NA. Here you can see the code which was implemented with H2O. As you can see, it's straightforward, it's easy to implement, so you will just import your package as if you are doing with any other packages. Then you will initiate your H2O service, because as I said, like H2O will enable you to have parallelized computing, so you can give it like the number of nodes that you want for your server. And then you can, for this one, as I said, like H2O has internal data structure. So when you are working with H2O, you need to convert your data set into an H2O data frame. So here you can see, like, you will just give it like H2O frame, so it will convert it to an H2O data frame, and it's basically like Pandas data frame. It's easy to play around with. And then we have to implement the model. And again, like here, H2O is giving you a lot of a set of wide range of parameters that you can tune, you can play around with to understand how your model is working, and you can give it a lot of parameters, and even you can play around with the hyperparameters that you can choose. Then you will just train the model based on the models that you implemented. Then you will predict it, and then you have to convert it back if you want to. If you are more confident with Pandas, you can convert it back as data frame of Panda, then you can do more, like to explore more your predicted data. The next model that we used was deep learning with autoencoder, and the main reason of implementing this model was it's giving us more generalized and scalable solution. And what is deep learning is it's unsupervised learning based on multi-layer feed-forward neural network, and it's taking the most important pattern, it's learning the most important pattern of the data and recomputing for you the original database based. So first of all, when it takes the input of your data set, it will convert it to a hidden layer. Then in this hidden layer, you have backpropagation, which is giving a small loss function that it will allow you to, it will make sure that when it's reconstructing your data, it will give you a most similar to your original database. So as I said, like one of the main characteristic was it's giving us a generalized and scalable solution. Here you can see the codes, and as I said, like again, it was with H2O. It's pretty straightforward. It's the same steps. You will just have to play around with the with the parameters based on the problem that you have, and you have a wide range of parameters that you can choose from the H2O. Then the next phase now, like we created a history of our data set, which is completed because one of the main parameter of recommender system is one of the fundamental one is to have a completed history of user preference. So after that, we will not give all this history to present it to the customer. We need to have a mechanism to rank the houses that we have to the customer based on their preference. And that's why we have the second phase of the project, which is like scoring. We presented a new scoring formula. And the goal of this one is just, as I said, like to create a ranking mechanism to give us back the houses from most similar to least similar based on the features that was selected by the user. And this formula was inspired by Lucene score formula, and we customize it based on our data set, and we give it a variable importance, which is like custom variable importance. So let's say, for example, we have total bathroom and total bedroom were more important than, let's say, fireplace or porch in this case. And as well as the score was weighting more the houses which was totally matching the customer preferences. So now enough with the boring theory. Chiara will present for you the result, and will show you a practical demo.
Thanks. So during our work, we also have carried out a very lightweight application implemented in Flask. What is Flask? How many of you have ever implemented an application in Flask? Okay, not so much. So I can introduce a little bit of Flask. So Flask is a web framework for Python that gives you the tools, the library, and the technology to implement a web application. It's a micro framework. This is really simple and lightweight, but support also extension to add functionality to the application, like, for example, form validation or database uploading, and so on. Moreover, it's really simple because it has only two dependencies, the Workzeug and Jinja. Workzeug is an utility library that permits the web server to connect with the web application. Instead, Jinja is a template language that permits to have a really dynamic HTML pages, so to have request and response and so on. And really important is that Flask is really easy to learn and simple to use. Now I will proceed with an example. Is an excerpt of our application final that I will show you later. And like the basic points of the Flask application, after obviously starting it and setting the variable of the environment, are the root. What are the root? These roots are different URLs that the application implements. And these roots are technically saying to the application which URL trigger a particular function. In this case, I will not go in detail in the code. I will only show some interesting stuff. There are, for example, the render template. You can implement the Flask with an HTML page, and the request form. So from a previous page, you can request some data that were inserted by the user. On the left, we have put some example code to run the Flask application on your local PC, so to test it, to see if it's working, and so on. Now, let's go to the results of our project. First of all, the validation of the model. So this plot is showing the percentage of error with the increasing of the missing value inside a query. So, because for tuning the model, we are saying that we are imputing some missing values inside a query. So, how can we say, okay, this model is okay, this model is not? So, we removed some random features from a random query, and we imputed with GLRM or deep learning with some parameters. And we compare these two. So, we compare the predicted query with the previous one, the original one, with the features original. In this case, we are showing the GLRM with 10 dimension and 15 dimension, and that is the pink line. And for the deep learning, we choose 250 nodes for the hidden layer, and 150 and 200 nodes for the hidden layer. As you can see, the blue line is always lower than the pink line. So meaning that the deep learning has a lower error than GLRM. In particular, has about 10% lower error than GLRM. Another thing to notice is that I think is reasonably reason. We have with the increasing of the missing value inside a query, the error is increasing because we have less information about what the user wants, and so we can't really be precise in our inferring. Last thing to notice about this plot is about the performance of the GLRM at the beginning. The performance of the GLRM is similar to the one of the deep learning without encoder, but only at the beginning when we have like more information and few missing value. Before proceeding with the final application, there is an example. No, sorry, I forgot. Okay, we already said that deep learning without encoder performs better. It has a lower error of 10%, but GLRM is faster. That is because deep learning without encoder need more time to process, is more complex, and so on. This table is showing the time in seconds needed for a complete run of the engine, meaning that we, from the imputing of the missing values to the ranking of the houses. So in this case, we are showing only from 40% of missing value on, and we can see that the GLRM has always a smaller time. And the GLRM practically takes from 30% to half the time of the deep learning without encoder. Another interesting thing is that with the increasing of the missing value, the time is decreasing, meaning that we have less information to process, so it's taking less time. Now, a first example, only to show you from also like a visual point of view, like the different way of inferring for the deep learning and the GLRM. So let's imagine that there is this user that wants this kind of features. So 1 bathroom, 4 or more bedroom, and so on. Now let's see how the deep learning and the GLRM are inferring the other features. Always keep in mind that we are only showing like some feature, an excerpt, but there are also a lot of other features that can be inferred differently between GLRM and deep learning without encoder. So these are the results. We added only to show like air conditioning, fireplace, and total room. For what concerns air conditioning and fireplace, there are no difference between the training of GLRM and deep learning without encoder. But what happens in total room? In total room, there is a difference. Like, only for a reasoning point of view, not really like statistical model or mathematical model, you can see that the user wants 4 bedrooms, a separate dining room. You have a kitchen and 2 or more living room. How much is the total? 8. So from this point of view, like, you can see that deep learning without encoder is predicting better. Now, let's see the ranking of the houses. Keep in mind these 2 queries because the rank is based on these 2 queries. And obviously of all the other features that are inferred. So these are the first 2 ranked houses for the GLRM and the deep learning without encoder. Let's remind what the user wants. So now, if we can see the matching between the query and the ranked house, for the GLRM, we can see that for the first house, the GLRM suggests, so the rankings for the query estimated with the GLRM suggests a house with only a bedroom. That is the only mismatch with what the user wants. But like a bedroom, if you want 4 or more bedroom, is not really like a good suggestion. For what concerns instead the deep learning without encoder, we have always the same amount of matching. But like the first ranked house has like more bathroom. So there is a mismatch always in bathroom, but we have like more bathroom. Do you prefer to like someone suggests to you like a house with more bathroom that you want or less bedroom? I think the second one, or at least I think that. And you have to keep in mind that this query, these features of the houses that like the user select are very particular. So they are not in our data set, our final data set, and so the engine should suggest something like that the user can appreciate. So now let's go to the interesting part. I will show you directly the application that we have done with Flask. So we have this application that we can, this is the welcoming, the homepage. Then you can like go with the user profile, it shows your age,